Hi guys. There are lots of basic things which you have got to keep in mind when we are dealing with physical chemistry. So my main contention over here is just to make you aware about, maybe you may be aware, but I just felt like making you aware about the basic requirement that we need for solving physical chemistry numericals. Alright, so to begin with, N is the number of moles, which is mass of substance over molar mass. Alright, or it could also be mass of substance over atomic mass. Alright, now for example, if mass of sodium I have given you is 160 grams, and we know molar mass of sodium is 23. So number of moles would be 160 divided by 23, that comes to 6.96, and it's unitless because both are grams. So gram gets cancelled and it gets unitless. Now let's talk about mole fraction of solute and solution. Suppose I have given you sugar solution, right? So it has got solute, which is sugar, and solvent, which is water, and the mixture is solution. All right, so always keep in mind number 2 whenever we put in, that is always for solute. So x2, moles of fraction of solute, is equal to moles of solute divided by total moles of solution. Now solute, now number of moles, say it is N2 of solute, and we just now learned how to find out number of moles. Now N2 divided by N1 plus N2, where N1 is number of moles of solvent. So X2 is equal to N2 divided by N1 plus N2. Alright, then again, if we come for X1, mole fraction of solvent, moles of solvent divided by total moles of solution. Obviously, it would also be N1 divided by N1 plus L2. Another fact that you have got to keep in mind is X1, that is mole fraction of 1 plus mole fraction of 2 is always 1. I've just given you an explanation why is it so. N1 divided by N1 plus N2, this is N2 divided by N1 plus L2. If you take LCM, then the denominator would be N1 plus N2 and the numerator also would be N1 plus N2 as denominator is common. So the value would be 1. So X1 plus X2 is equal to 1. So if in a sum I have found out X2, I need not find out X1 because I can just subtract that from 1. So similarly here, as I have shown, X2 is equal to 1 minus X1. Alright, so just a small example I have given. Mole fraction of sugar in solution is 0.3. Now as I told you, solute, sugar is solute, so 2. X2 is known, 0.3. So mole fraction of water would be 1 minus 0.3 is 0.7, which is equal to X1. Alright, then coming to a relationship which is very worthy. Coming to a relationship which is really worthy. Now the relationship which you have always to keep in mind is 1 mole corresponds to molar mass of a substance. Alright, and that corresponds to 22.4 liter or decimeter cube. That also corresponds to 6.022 into 10 raised to 23 molecules, atoms or particles. That also corresponds to 96500 coulomb, which corresponds to 1 Faraday. So this relationship would be very helpful in many places. Alright, let's move ahead. Let's try and understand relationship between molecular formula and empirical formula. Molecular formula is equal to N into empirical formula. Empirical formula is simplest ratio of elements in a compound. Now for example, C6H12O6 is the molecular formula. The simplest form is what? CH2O. The simplest ratio of element in a compound, that is 1 of C and 2 of H and 1 of oxygen. When you multiply it with a number N, we get, alright, so that's the relationship between empirical formula and molecular formula. So molecular formula is equal to N into empirical formula. Similarly, if we intend to find out molecular formula weight, and if we are given N, then what do? We just divide molecular formula weight by N to get the empirical formula weight. Similarly, we can also find out molecular formula weight by summing up the atomic weights here. So we can find out molecular formula weight that ways, empirical formula weight that ways by summing up the atomic weights of individual atoms. And if I divide molecular formula weight by empirical formula weight, then I can get N. Alright, so this is the relationship that I want to keep in mind. Then coming back to the basic things that we require is molarity, molality, and normality. Molarity is number of moles of solute divided by volume of solution in liters. Molality is number of moles of solute divided by volume of solvent in kg. Mind you, we saw two differences in between molarity and molality. Here it was solution, whereas here it was solvent. Here it was liters and here it was kg. Alright. Now molarity is sensitive to temperature, because suppose if I make a solution, 1 liter solution of hot water. So when the water cools, the volume decreases. As a result of that, molarity increases. Alright, so it's sensitive. Whereas if I prepare a solution in 1 kg of solvent, say water, so even after cooling, it would stay 1 kg only. So there won't be any change in molality. So molarity is sensitive to temperature. Then normality. So what is normality? Normality is gram equivalent weight of solute divided by volume of solution in liter. Gram equivalent weight is weight upon equivalent weight. And equivalent weight is molar mass upon number of replaceable H plus, OH minus, or whatever is the charge of metal ion. Now for example, if I take HCl. Now HCl molar mass is 36.5. So it has got one replaceable hydrogen. So it would be divided by 1. So it would remain 36.5 itself, the equivalent weight. Whereas if I take sulfuric acid, H2SO4, its molecular weight is 98 grams. Alright, so and it has got two replaceable hydrogen. So 98 divided by 2. So that would be 49. So equivalent weight would be half in case of sulfuric acid. Now sodium hydroxide. Sodium hydroxide we know is 40. Alright, 40 divided by 1 hydroxy. So 1 divided by 1. Alright, silver. Now if I take silver metal, silver 108 grams atomic weight divided by charge plus 1. Alright, so that's how we take out equivalent weight. Alright, I also need to bring to your notice is this also, normality is also liters, solution in liters. So normality is also sensitive to temperature. Alright. So what I have next is percentage composition of constituent element. I have been asked to find percentage chromium in K2Cr2O7, where chromium atomic mass is 52, whereas K2Cr2O7 is 294 grams per mole. Alright. Now, so how do we find? It is mass of element in 1 mole of compound upon molar mass of compound into 100. So mass of element, our requirement is chromium. Now keep in mind it is Cr2 and they have given the atomic mass of chromium is 52. So we obviously have got to multiply 52 by 2. So it becomes 104 divided by 294. That comes to 35.37. So this is how we find out percentage composition of constituent in an element. Alright.